Hello, in this video we're going to talk about binary and unary operation. So the binary operation is an operation where you have two elements, for example xy or yx, and some operation in between. For example, addition. So x plus y would be an operation, binary operation, or y plus x. And the same with subtraction, multiplication on z. For example, 2 plus 3 or 3 plus 2 and so on. And so unary operation is done on a single element, such as negation. So an ordered pair of elements is written as xy and is different from yx. Because of course, if sometimes when you write 2 minus 3, it will be different than 3 minus 2. Two ordered pairs A, B and C, D are equal if and only if A equal to B and B equal to C. So if S, for example, 2, 3, the ordered pair 2, 2, 2, 3 and 3, 2, 3, 3, they are different. So the binary operation represented by this circle, it could be, this is just placeholder for any operation, could be addition, subtraction, or something you create. On a set is defined as follow. So if for every ordered pair xy of element on S, this is very important. Where are we talking about? What set are we having this element from? Are they in all integers or are they all real, and so on? So x operation y exists. So for it to be defined, it must exist, it must be unique, and it must be a member of S. And I will explain this. Exist, unique, and S, a member of S. So the fact that this operation exists and unique is the same as saying the binary operation is well defined. So for it to be well defined, it must exist, unique, and it must have a closure, which means a member of S. So let's see, I'll make up some operation. It doesn't have to be addition or subtraction, but I'm gonna make up just if I have a set S, and my set S is, maybe I even choose not letter A, B, C, and D, and E. Okay? So, and my operation will be a square, whatever, it's a placeholder. So A, B, C, D, E, A, B, C, D, E. So for example, my entry, I decided that A, square A will give me A, and B, and C, and D. I'm making up stuff here. But this one, maybe it will be all B and C and then E and D and so on. So here we are. So for example, does it exist? Yes. So between A, B, C, D, E and another A, B, C, D, E, this operation A, B, A, C, A, D and so on, or B, A. So it does exist, there is some entry, there is a result, it does exist, and it is unique. That means, what does it mean unique? That means when I do A operation with B, I don't get two entries, I get only one. So for example, A, B, I get just B. I don't get a different answer, so only one entry. So that's what unique means. And is a member of S. That means, is everything I have here in blue is part of S. If it is member of S, we say there is a closure, is closed under S. If all of a sudden I end up with something like, I don't know, X here, there is no closure here, because this X is not part of my S. So S can be a real number or Z or whatever. And now, based on these three things, exist, unique, and it is a member. So let me go back and make up this as whatever is a member of S, maybe C. So based on these three things, then I could say this operation that I just made up now is defined. is well defined. Okay, so let's see examples here. Which of the following candidates are binary unary operation on the given set? On the given set, for example, here the set is n, or set natural number, which includes 0, 1, 2, 3. This is integer, and this one. So based on this, let's see which one, if it is binary or not, and if it's not, we have to state why it fails. Why is it not a binary or unary operation? So here where we have x operation with y, it's basically x plus 1 on n. So pick x's from n, that means 0, 1, 2, and so on. Remember, this book includes the 0 as a natural number. So if I pick any number from here, from this set S, and I add 1 to it, am I still gonna be in S? Or which is my result still a natural number? Yes. Do I have a unique result? Yes, I don't have two results, and it does exist. And therefore I would say yes, this is a binary operation. Of course, I will explain it. Three things: it does exist, it's unique, and closed. That means my result is within n. Let's see the other example. Still, I'm in natural numbers, and then what we have? We have an operation x and y. So you pick x and y from the set n, 0, 1, 2, and so on. And then, so if I do 1 plus 1 minus 1, or 0 plus 0 minus 1, would my answer always exist and unique and closed? So I'm sure if I pick any x and y from this set, it does exist. I will get some result, and it is unique. But is it closed? Is my answer always within n? Well, if I pick 0 plus 0, that means x is 0 and y is 0 minus 1. My answer is negative 1. Well, this does not belong to n. So not closed. So not closed, and therefore binary operation is not defined, or it's not a binary operation. Why? Because it's not closed. As you see, when I pick 0, 0, all of a sudden my answer is negative 1, and it's not within n. If S was a Z, then it will be defined and it will be closed, because negative 1 is in Z, which is set of all integers. Let's see this one here. Is this a binary or not? Okay, so my operation is defined as follow. So if x is odd, so again I'm picking from Z, and Z can be any number like minus 2, minus 1, 0, 1, and 2, and so on. So you pick an integer, and then if it is odd, if x is odd like 1, then it becomes x minus 1. If it is an even, just x. So my operation, binary operation, it does exist. I always get some answer, and it is unique. It's like when I pick a number, I don't get two answers for that number, so it's only one result. And it is closed because every time I do this operation, I pick either odd or even, I will get some number which is part of Z, and therefore it is a binary operation. Let's see this one here. The set of n, which is again 0, 1, and 2. And then if I pick x and y from this set, so if I pick x and y from n, does the result exist? And we see that it does, because it's always gonna be something within n, which tells me it's closed, and it tells me it's unique. You don't get two minimums, you always get one minimum, even if x equal to y. So my answer here is that this is a binary operation. So assume I have another one here. For example, x, and with this symbol, equal ln x. Is this a unary operation? But again, s is all real number. So what does it mean? If I pick any x from the real number and plug it here, does it exist? Well, the existence fell, because how about if I pick 0? ln 0 doesn't exist. Okay, and therefore this is not unary operation. Of course, if I pick any x less than 0 or equal, doesn't exist. So it is not a unary operation.